It's now time for CSEC Chemistry. I'm your teacher, Andrea Knight Blackwood. Today's topic is mole concept. At the end of the lesson, you should be able to apply the mole concept to equations. You should be able to define the term standard solution. And also, you should be able to perform calculations on mass and molar mass. So, a recap. Question. Jamal has only 11 grams of potassium hydroxide and wants to know what mass of potassium sulfate he could produce if he reacts this with excess sulfuric acid. So here we have three questions. The first one, how many moles of potassium hydroxide does Jamal have? So we're going to go to the whiteboard. All right. So the first thing, when I see a question like that, the first thing I would do is to write my equation, because we need to see what we're working with. All right? So we have potassium hydroxide reacting with potassium sulfate. Potassium hydroxide reacting with sulfuric acid. So we have potassium hydroxide reacting with sulfuric acid to give us potassium sulfate and water. And we know the next thing to do is to balance the equation. So we balance the equation by counting how many potassiums are on this side and how many are on this side. So here we only have one potassium, here we have two. So we balance our equation by putting a 2 here. So we can balance the potassium. So now we have 2 potassium, now we have 2 potassium. So that's fine. So the next thing to do is to balance our sulfate. Now my sulfate ion is SO4, and I have SO4 still intact on the right-hand side. So my sulfate is balanced. I have 1 and I have 1 there. So when we're balancing our equations, we have to remember to balance the hydrogens and the oxygens last. All right, so let's look at our hydrogens. I have 2 hydrogens here and 2 here. That makes 4 on the left-hand side, and I only have 2 on that side. Okay? So I need to put 2 there. So 2 2s, 4. Okay? So the final thing is to balance the oxygens. Now, we already counted this oxygen, so we're not going to include that in our counting. So 2 oxygens here, and we have 2 there, so we're balanced. So let's put in our states. So you know it's 1 mark for our states. So we know that all group 1 elements are soluble. All sulfates are soluble. So putting our states, we must remember our solubility rule. So all group 1 elements are soluble, and of course water is pure, so it is a liquid. So let's continue. It says how many moles of potassium hydroxide does Jamal have? So here we're given 11 grams of potassium hydroxide. So how many moles? How do we get moles from grams? We need to calculate molar mass. So potassium we know is 39, oxygen is 16, hydrogen is 1. So let's add this and see how much we get. That's 56. What is our unit for molar mass? That's right, CMR, grams per mole. So that's 56 grams per mole. So how do I know what to do in order to get mole? First, I look at my units. I must always look at my units in order to get what I want. So the question is asking me for moles, and here I have 11 grams. So what I need to do is to divide 11 by 56 grams per mole, and I'll get my answer. So let's put that in our calculators. Okay, so that's 11 divided by 56. And my answer, I'm going to put it to 3 decimal places. That's 0.196 mole. It is per mole here, and we're dividing. So at the end, it becomes mole. So that is our answer for potassium hydroxide. So we have answered number 1. Let us move to part 2. How many moles of potassium sulfate would Jamal be able to produce? So again, that's where balancing our equation comes in. It is very important to balance our equation. So this is a 2 let's look at the mole ratio. The mole ratio here is telling me that it requires 2 moles of potassium hydroxide to produce 1 mole of potassium sulfate. So, based on that, I am seeing that I used 0.196 mole. So how much of potassium sulfate would be produced? So what I have to do now, it's 2 to 1, so it means that I have to divide by 2 in order to get my answer for potassium sulfate. So I'm going to divide 0.196 by 2, and my answer for potassium sulfate should be 0.098. And of course, it's wrong without the unit. We have to always remember the unit. So that's 0.098 moles. All right, and our final question, what mass of potassium sulfate could Jamal use? So it's asking us for mass. So what is our unit for mass? That's right, grams. All right, so how do we convert from moles to mass? Okay, so what we're going to do, we have to calculate the molar mass for potassium sulfate. So I'll tell you before, the molar mass for potassium sulfate is 174.2. So you can work it out for yourselves. Okay, so I'm going to use the number of moles that I have of potassium sulfate, that's mole, and the molar mass is 14.2 gram per mole. So we have these two things and we need to get grams. How do I get grams from this? I am looking at moles and I look at per mole here. I need grams. So based on the units that I have, I know that I have to multiply for these two to cancel because they're opposite. So 0.098 mole times 174.2 gram per mole. My answer should be equal to grams. So work it and tell me what you got. Ruth Ann, what did you get? I have to confirm your answer. Let's go. So 0.098 times 174.2, and I got 17 grams. All right, let's move on to what we're actually doing today. So we're going to look at molar and mass concentration. So what is concentration? Ever heard of people saying that that is a concentrated solution, syrup is very concentrated? What are they talking about? All right, so what concentration really is talking about is the amount of solute dissolved in a given dissolved in a given volume of a solution. For example, the amount of salt dissolved in water. So the greater the amount of solute dissolved, the higher the concentration of the solution. There are 3 types of solution. We have dilute solution, we have concentrated solution, and of course we have a saturated solution. Saturated solution just means that the maximum solute is dissolved in the solvent. All right, so we're going to focus on concentrated solutions. So here is a visual for visual learners. So here we have our solvent being blue and our solute in red. Okay, so here, which of these would you think that is a dilute solution and which would you think is a concentrated solution? Take a minute, not a minute, maybe a second. Yes, Siomar, you got it correct. This is a concentrated solution. Why? Because it has more solute dissolved in the solvent. All right, so let's look at our units that we use when we're doing concentration. So remember that concentration really refers to the amount of solute that is dissolved in the solvent. All right, so our solute is normally measured in grams, or we can use moles. And our volume is centimeter cube, which we use a bigger unit, which is dm cube. Dm cube is the same as liters. All right. So here's how we calculate our concentration. concentration is divided by, mass of a solute is divided by the volume of the solution. So our units for concentration is gram per dm cube. Also, if we're using moles, the unit for concentration will be mole per dm cube. And we call this form molarity. We refer to it as molarity, but it's really the same thing. The mass of the solute, which is given in moles, divided by the volume, which is dm cube. Okay, so really, molarity is what chemists use, and when we say molarity, we're talking about molar concentration, and we use the letter M, but it's a big M. So sometimes when you look at your concentrated solution like sulfuric acid in the lab, you'll see the concentration there on it, and you'll see a big M. So the M just means molarity. All right, so let's try a calculation. Let's try one. All right, so 0.5 mole of sodium chloride dissolved in 1 dm cube of distilled water. I want you to find the molarity for that solution, for number 1. So, what is the first thing that you think we should do what is the first thing you think we should do to convert this to molarity? Ruthann, is that an answer? Am I hearing the answer, Ruthann, from you? Okay, so what we're going to do, 0.5 moles divided by 1 dm cube. My answer will still be 0.5 moles per dm cube. So that is the molarity for number 1. So number 2, if we're to do number 2, it would be 0.2 moles divided by, we can't divide by 250 because it's in centimeter cube. The unit for concentration is dm cube, so it's mole per dm cube. So here we have 0.2 moles, and we have that is dissolved in 250 cm cube. Now this cm cube has to be converted to dm cube. How do we convert from cm cube to dm cube? That's right, we divide by 1,000. So dividing 250 by 1,000, we move 3 spaces to the left. So 1, 2, 3. And my answer will be 0.25 dm cube. So I'm going to divide 0.2 by 0.25. So what will my answer be, CMR? That's right, 0.8. What is the unit? 0.8 mole per dm cube. All right. Here I have a little illustration right there to show you how to convert from molarity to concentration, from mole per dm cube to gram per dm cube. So to convert from mole per dm cube to gram per dm cube, we multiply by molar mass. And to convert from gram per dm cube back to mole per dm cube, we divide by molar mass. So let's look at this question. 0.2 mole of sodium hydroxide is dissolved in 250 cm cube of water. Calculate the concentration of the solution obtained in units of gram per dm cube. So now we're given mole and we're given cm cube. I need to convert this to gram per dm cube. We just did that a while ago. So how would we calculate it? So 0.2 mole divided by 0.25 dm cube. My answer will be 0.8 mole per dm cube. So we did that just now. So we did that just now, so that's B. So how do we convert from this to gram per dm cube? According to the top, we move from mole per dm cube to gram per dm cube. We multiply by molar mass. And it's given in the question. The molar mass for Sodium hydroxide is 40, so we multiply this by 40. And what's the unit? It's gram per mole. So mole will cancel per mole, and my answer will be gram per dm cube. Sorry. Okay. So let's do this calculation. 0.8 times 40. And that's 32 grams per dm cube. Okay, let's continue. Calculate the mass of sodium nitrate to be added in 100 cm cube of water to produce a solution with concentration of 0.02 mole per dm cube. How do you think we are going to do this question? What is it that we're to do? It says calculate the mass. So they're asking us for mass. So what is the unit for mass again? That's right, it's gram. It's grams. So here we have centimeter cube, which is our volume, and we have concentration. So let's see if you can do this question. So here we have 0.02 mole per dm cube. And of course, we're going to convert our 100 cm cube to dm cube. So we divide by 1,000. So having this, we see that they're opposite. So we multiply this by 0.1. These two will cancel. And my answer should be 0.0. Let me do this in my calculator. Not trusting my head right now. Yep, 0.02 moles. All right, but the question is still asking us for grams. So what do we do? Now, the molar mass for sodium nitrate is given in the question, so it's 85 grams per mole. So I need to convert this to grams. So I have 85 grams per mole. So I need to multiply that again so that these two will cancel, and my answer will be in grams. So 0.002 times 85, my answer is 0.17 grams. Yay. One more question. All right, so 0.4 grams of glucose is added into 100 cm cube to prepare a glucose solution with concentration of 0.025 mole per dm cube. Calculate the relative molecular mass of glucose. Now, the relative molecular mass mass of glucose, what is the unit? Now, if we're doing relative molecular mass, we know that we should have something looking like gram per mole. So we need to, what is it that we need to do? We have mole per dm cube, we have 100 cm cube, and we have 0.45 grams. Let's give you a second to think about how to do it. And Ruth, and I want you to do this one for me. Okay, so the first thing we're going to do, we're going to convert our 100 cm cube to dm cube, and then we're going to multiply it by the concentration, which is 0.025 mole per dm cube. So when we convert our volume, which is 100 cm cube, to dm cube, we would get 0.1 dm cube. So multiplying that by our concentration, so 0.025 mole per dm cube times our volume converted to dm cube, that will give us 0.025 moles. And then, what do we do next? It is asking us for molecular mass. We have to remember that. So we know that our answer should be in somewhat gram per mole. So here we have moles, and we are given 0.45 grams of glucose. So I want you to pay attention carefully. Look. So here, this is my answer. My answer should be in gram per mole. Here I have moles, and the question gave me 0.45 grams. All right, so I have gram and I have moles. What do I do to get gram per mole? I want per mole, so I know that I have to divide by that. So if I divide 0.45 grams by 0.025 moles, my answer will be 180 gram per mole. And that is the molecular mass for glucose. Okay? All right, let's see if the molar mass for glucose is correct. Glucose is C6H12O6. That means 6 carbon, 12 hydrogens, and 6 oxygens. So my carbon is 12 times 6 plus 12 hydrogens times 1 plus 16 times 6. So let's work this to see what the molar mass is. So 16 times 6 Okay, so 16 times 6 is 96 plus 12 plus 12 times 6 is 72. Add all of these together and I'll get 180 grams per mole. So my calculation above was correct. So let's summarize. Now, molarity is equal to number of moles divided by volume of solution. And the unit for molarity is mole per dm cube. Right? Now, molarity is equal to number of moles over volume. N is equal to number of moles. Oh my God. N is equal to number of moles, while volume is equal to, well, V is equal to volume of solution. So M is equal to N over V. And here we can substitute this equation above to calculate number of moles. So number of moles is equal to molarity times volume to get number of moles, right? So, all right, let's do another. So again, let us recap concentration. So concentration is the amount of solute dissolved in a given volume of solution, while a standard solution. What is a standard solution? A standard solution is normally used by chemists, is normally used in the lab. A standard solution is a solution that is accurately known. The concentration is accurately known. So we normally use standard solution to do our titrations. So a standard solution is a solution in which its concentration is accurately known. All right. So let's see if we can answer all of these questions. So you should be able to apply the mole concept to equations, and you should be able to define standard solution, and also you should be able to calculate mass and molar concentrations. And that's it for today's class.